Hello students, today we are going to start the last question of exercise 8.2. We have finished all the questions of 8.2, only the question number 7 is remaining, and then we shall follow the proof of the theorem. There is only one theorem which we need to prove, and if the time remain, then we shall start the solved example as well. So let us see in the question number 7 what we have given here. ABC is a triangle right angled at C. A line through the midpoint M of hypotenuse AB and parallel to the BC intersect at D. There are many things are given in this question. Okay. First of all, we shall read the first line. Diagram I have drawn here. So see what they are saying. ABC is a triangle right angled at C. So here this point at the bottom I will suppose C over here because it is a point of right angle. So this point I am supposing as a right angle. Okay, and here I will mark the right angle as well, so it will be clear for us that we are supposing as a right angle. Then remaining these 2 points I can suppose A and B. Here I am supposing A, you can suppose B also, and here I am supposing B, you can take A also. Okay, only the location of C is fixed here. Now what they are saying further, a line through the midpoint M of hypotenuse AB, means we have given that one midpoint of the hypotenuse AB. The point is given there M. So here we shall suppose M is a midpoint of AB, that is given in the question, and so we can say that AM and BM will be equal. Now from the point M we have drawn one line which is parallel to the base BC. Okay, and that line will intersect the line AC at D, means from the point M if I draw the line, okay, so that line will be parallel to BC, one thing. Second thing, this line is intersecting AC at a point D, that is also given in the question. So we have given that in short MD is parallel to base BC. Second thing, now we have to prove here three things. D is a midpoint of AC, MD is perpendicular to AC, means D will be a midpoint as well as MD will be perpendicular. So D is a point of perpendicular also, means at a point D we can say that the angle is going to form of 90 degree. And the third thing, CM and AM, you are looking two sides in the triangle, one is CM and AM, both will be half of AB. Okay, so let us see how we can prove it. First of all, let us start the given over here. So in the given, first we'll mention triangle ABC is right triangle. Triangle ABC is a right triangle in which angle C will be equal to 90 degree, that is one given for us. Okay, and what else we have given? M is the midpoint of AB, that will mention M is a midpoint of AB, and one more thing we have given, from M the line we have drawn, that is MD, is parallel to the base BC, that is also given to us. So three things are given. Okay, now we shall write down to prove over here. So in the case to prove, we shall mention the section of to prove one by one all the three parts. First part is D is midpoint of AC, so that is first part. D is midpoint of BC. Second part, what we have required to prove here, MD is perpendicular to AC. And third part that we need to prove over here, CM is equal to AM, and they are equal as well as they are half of the hypotenuse AB. Okay, so let us start the proof. to us. Now in the proof, first we shall focus on how to prove D is a midpoint of AC. Okay, so see, first I am taking here in triangle ABC. You can see the triangle ABC over there. Now at the time you need to leave some things. Okay, for example, uh, C and M, the line we have joined over there. Okay, because it is required to prove CM and AM are equal. So for some time, forget the line CM. Look at triangle ABC. M is a midpoint, and from the point M, I have drawn a line parallel to the base BC. So we shall apply here converse of midpoint theorem. In the previous session, we have done very well the questions of converse of midpoint theorem. So if you have any confusion right now in the converse, again please see the previous session once again. Okay. So here in the converse of midpoint theorem, two things we required. One, we required the midpoint of one side of a triangle, and from that midpoint we should draw the parallel line to the base. Then that line is intersecting the another side at whichever point, that will be also midpoint of the that particular side. So here you see from the point M we have drawn a line parallel to the base BC, as well as M is a midpoint of the side AB as well. So by converse of midpoint theorem, D will be also midpoint of AC. That we can say very easily, and first part will get over. So see, here we shall write down in triangle ABC, M is a midpoint of AB, that is given to us in the question. And one more thing, MD is parallel to the base BC. Here reason we can provide, that is given. We have mentioned in the given as well. Now we can say that therefore by converse of midpoint theorem, okay, we shall apply the converse of midpoint theorem, and as I have told you just now, we can say that D is midpoint of side AC. Okay, and here we can say that we have proved the first part. Okay, now second part we have to prove here. In the second part, MD is perpendicular to AC. Okay, for that, here I will mark one angle at a point D. Here, suppose one angle, if I mark, the name of that angle is angle number 1. Now look at the side MD and BC carefully. Okay, again please do not see the side CM. If I draw specially for you here, suppose if I draw here, this is one line, this is another line, and this is the line AC is coming over there. Okay, please see it very carefully. So this point is M somewhere, this point is D, this is B, this one is C, and here somewhere A point is there, it is not required. So this one is marked as angle number 1 and this one is marked as angle number C. Now you observe MD and BC are parallel. Okay, if I extend the line MD and BC at some length, then you see it can look like in this manner. Okay, now you observe carefully angle 1 and angle C. For some time, if I say the angle C is my angle number 2, so observe both the angles are clearly looking as a corresponding angles. And we know that if lines are parallel, then corresponding angles are always equal. Okay, so here we can say that the angle 1 and angle C are corresponding and they will be equal because lines are parallel. Now we shall write down MD is parallel to BC. So MD is parallel to BC, that is given in the question. Okay, again we can mention here. Therefore we can say that angle 1 is equal to angle C, and that is with the help of corresponding angles. Okay, so angle 1 and angle C are equal, right? As you can see, both are corresponding angles. Okay, once we can see in the figure, angle 1 and angle C, as I have explained you earlier, these two are the corresponding angles on the parallel lines, and hence they are equal. Now angle C value already we have given as 90 degree. So we can say that, which implies that angle 1 is equal to 90 degree. Here we can say that since angle C is equal to 90 degree. And if angle 1 is of 90 degree, we can say that therefore MD is perpendicular to AC. Here we can say that we have proved the second part. Now first part and second part is over. Now we are going to prove the part number third. So in the part number third, see what we have given there. We have to prove that CM is equal to AM is equal to half of AB. So first we shall prove CM and AM are equal, because AM is already half of AB. So if CM and AM are equal, then we can say that they both will be half of AB, right? So here first of all we shall try to prove CM and AM are equal. Now see, in the part number 1 already we have proved D is a midpoint of AC. Okay, that we have proved in the part number 1. So AD and CD are equal, right? MD will be a common side between two triangles, triangle ADM and triangle CDM, and D is a point of perpendicular. So if I suppose this angle is angle number 2, so I can say that angle 1 and angle 2 both are 90 degree each. So we are trying to prove here the triangle ADM and triangle CDM are congruent, and if they become congruent, then with the help of CPCT, AM and CM will become equal over here, right? So let us see in triangle ADM and triangle CDM. Now we shall write down in triangle ADM and triangle CDM. Okay, first we are going to mention here. See, I have not drawn the figure here. So please see the main figure only. AD and CD are equal. MD common. So first we'll mention here AD and CD are equal. AD is equal to CD. You can see that this we have proved earlier. Okay, in the first part that we have proved already here. Proved earlier AD and CD are equal. Then we can say MD and MD common. So MD is equal to MD. That is common, right? And angle 1 and angle 2 both are equal to 90 degree each. So angle 1 is equal to angle 2. Reason we can give here each 90 degree. Okay, so we can say that therefore triangle ADM is congruent to triangle CDM. ADM and CDM both are congruent, right? How we can say both are congruent? With the help of side angle side congruency theorem. Okay, now if these two triangles are becoming congruent, we can say that thus AM and CM are equal. So AM is equal to CM with the help of CPC. As you can see in the main figure, these two sides will be the corresponding side, because already two sides we have used and they are corresponding. So the third pair remain, that will be also corresponding here. We know that, but AM is equal to half of AB. That is given in the question, that AM is half of AB or M is a midpoint of A. You can say that here, since M is a midpoint of M is a midpoint of A. Okay, that we have proved it, right? So now if AM is half of AB and AM and CM are equal, so sorry, so we can say that AM is equal to CM and they both will be half of A. Okay, this was the part number 3rd which was required to be proved, and we have proved it now. So this question get completes. It was little lengthy question, but I don't think this question you may felt difficult. Okay, this simple one. Only at last we have proved triangles congruent, and in this question you see we have used nearby each and every concept. Okay, so this complete the exercise 8.2. Now I am taking one proof of the theorem. The theorem is given as, see, the theorem is given as the diagonal divides a parallelogram into two congruent triangles. Means you are looking the parallelogram ABCD here. In this parallelogram, you are also looking the diagonal AC. Right? Now, this diagonal AC divide the parallelogram into two congruent triangles. You can see the diagonal divides the parallelogram into two triangles. Namely, one is ABC and second one is ACD. Okay. So these two triangles we have to prove congruent. That is a requirement of this theorem. Okay, this is a fact, this is a property. Okay, and we can use it this fact in the some other chapter as well. So let us see how we can prove it. One thing remember, we are proving two triangles congruent. So we have only one of the way out of these: angle side angle, or SSS, side you can say, or you can say the right hypotenuse side. Right hypotenuse side will not be applicable because here none of the angle is given to us 90 degree. So out of the three remaining, that we will use it any one. So first I will write down here given. So in the given, first we will mention ABCD is a parallelogram. ABCD is a parallelogram that is given to us, and one more thing is given, AC is its diagonal. The second thing is given, AC is one of its diagonal. Okay, now what we need to prove here, that will mention. Now while writing the name of triangle, we need to be little more careful because it should come according to the one-to-one corresponding. So for that, it will be easier for me and you also that we shall make one triangle. So here make one pair of triangle here. This is one triangle I have drawn, and one more I will take it here. Okay, here in this triangle we can shift a little bit over there. Now first I will give the name over here. I will suppose this angle as angle number 1. Okay, first of all we shall mark this angle as angle number 1, and the second angle I am marking over here as angle number 2. This angle I am marking 3, and this I am marking as 4. One thing is very clear, side AC means diagonal AC will be here a common side between both the triangles. So AC we can mark over there. First of all, we can see angle 1 and angle 2. They both are alternate interior angles. And since we know that ABCD is a parallelogram, so definitely AB and CD will be parallel. So angle 1 and angle 2 will be equal. In the same manner, if I take AD and BC are parallel, so angle 3 and angle 4 will be also equal because they are also alternate interior angles. So here, first we shall try to mark angle 1 and angle 2 with their proper names. So angle 1 is here DCA. Suppose if I mark this one as DCA, so this will be my angle number 1. Okay. Now See the angle number 2. That will be CAB. CAB if I take, then CA should corresponding to side CA should come because both are common. So here if I take in place of CAB, if I take B, A, and here if I take C, then again this will be angle number 2 only. Okay, you can say CAB or you can say BAC. Starting point you can keep B or C over there, but now you see CA and AC are correspondingly they are equal. Now next is angle number 3 and angle number 4. So DAC, observe DAC is coming here. This is our angle number 3. So I will mark this one dot and this is cross. Okay, so we can understand these are angle the equal over here. And angle number 4 you can see ACB. So this will be the angle number 4 we can say, and hence this is also equal. Okay, so now let us see how we can prove it. These two triangles are congruent. Observe here AC and AC are equal. So now I think it is clear to you, by angle side angle easily we can prove these two triangles congruent. So now you see, first I will write down the name. Now my names are set according to the one-to-one correspondence. Triangle DCA is correspondingly congruent to the triangle PAC. Okay, let us start the proof. So in the proof, first we shall write down in triangle DCA and triangle BAC. Okay, first we shall mention here angle 1 is equal to angle number 2 and angle 3 is equal to angle number 4. Here reason we will give, since ABCD is a parallelogram, ABCD is a parallelogram, therefore AB is parallel to CD, comma AD is parallel to BC, because both the lines will be parallel, and if the lines are parallel then alternate angles will be equal. Okay, so this complete the reason. Now we can say one more thing here, and AC will be equal to AC, that is common. Sorry, AC, in place of AC in the first triangle you see the name is coming CA, so we shall write down accordingly CA is equal to AC. So here we shall write down AC, CA is equal to AC, that is common. Okay, so we can say that therefore triangle DCA is congruent to triangle BAC. That is with the help of bi-angle side angle rule, and hence we can say that the required task is get over. Let us see the next question. Now we will take some solved examples. Solved examples are given in the textbook, that is actually solved only. You can see the solution and you can find out very easily, but some of the solved examples are given in a very ideal form, and that solved examples, if comes in the examination directly, you won't be able to solve it until and unless you solved it earlier. So we will do one thing, we shall solve all the examples. Let us see the first example we have given here. Show that each angle of a rectangle is a right angle. So basically we know that every angle of a rectangle is of 90 degree, but it is not a fact. That is however further improved, or we can say that is further proved. Means basically a rectangle is a parallelogram with one angle sorry, one angle is of 90 degree. Means we can say that the definition says rectangle is a parallelogram with one angle is of 90 degree each. Okay, the remaining three angles, they have not anything, they have not told to us. So we have further proved it. The remaining three angles are also 90 degree each. And then when we take when we consider the angles of a rectangle, we say that all four angles are of 90 degree. So here we are going to prove the remaining three angles are only 90 degree each. Okay, so let us see. First we shall write down the given things. Here we have given that ABCD is a rectangle. So we shall write down ABCD is a rectangle. It is given to us. To prove, here I will mention all the four angles because they are saying show that each angle of a rectangle is right angle. So we shall mention all the four angles. Angle A is equal to angle B is equal to angle C is equal to angle B is equal to 90 degree. Now proof. So first in the proof we will mention the basic definition which we have given for the rectangle. So here we shall write down since we know that every rectangle is a parallelogram. Every rectangle is a parallelogram with one angle is 90 degree. Okay, so we can say that therefore in rectangle ABCD, see they are saying it is a parallelogram, and in parallelogram what we know, the opposite sides are parallel. So we can say that in rectangle ABCD, we can say that AB is parallel to CD, comma AD is equal to BC, and one angle is given 90 degree. So angle A will be equal to 90 degree. That we can say here. Now see, one angle is of 90 degree. Now you see, we know that in a parallelogram the angle opposite to each other are equal. So if angle A is equal to 90 degree, C will be also 90 degree. And if we are able to prove angle B is of 90 degree, so angle D will be also 90 degree because both are opposite to each other, and in parallelogram the angle opposite to each other are equal. Okay, so here we have to prove basically one more thing, angle B is of 90 degree. So here we shall say now angle A plus angle B is equal to 180 degree. How you can say? You observe angle A and angle B are interior angles, and these interior angles we have made on parallel lines. Okay, you can check the ABCD rectangle, angle A and angle B are interior angles, so their sum will be equal to 180 degree. So here we can say that angle A is equal to 90 degree plus angle B is equal to 180 degree. Okay, angle A value I have kept here, and 90 if I send on that side, so angle B will be equal to 90 degree over there. Now we shall write down at last, since angle A is equal to angle C and angle B is equal to angle D, we can say that since ABCD is parallelogram, also therefore opposite angles of parallelogram, and opposite angles of parallelogram are also equal. So here we can say that now angle A and angle B we got as 90 degree each here. So we can say that angle C will be equal to 90 degree and angle D will be also equal to 90 degree each. So now we can say that therefore angle A is equal to angle B is equal to angle C is equal to angle D. All four angles are equal to 90 degree each. Now this example got over. Let us see the next example. Now see, in the next example, what we have given? Example number 2. Here we have given that show that the diagonal of a rhombus are perpendicular to each other. Remember, rhombus is also a parallelogram basically. So properties of parallelogram we can simply apply on rhombus as well. And what we need to prove here? The diagonals are perpendicular to each other. Observe where diagonals are intersecting. Diagonals are intersecting at a point O. So we have to prove that at a point O, whichever the angles are going to form, that angles are 90 degree each. And we need not to prove all the angles at a point O going to form any one angle. If I prove 90 degree, then remaining angles with the help of linear pair and with the help of vertically opposite angles, easily we can find out they are also 90 degree each. Okay. So first we shall write down the given things here. What we have given here? We have given that ABCD is a rhombus. ABCD is a rhombus. That is given to us. Now, further, what they are telling to prove here. So, we shall write down to prove. What we need to prove over here? We need to prove that angle AOB is equal to angle BOC is equal to angle COD is equal to angle DOA. These four angles basically we have to prove that 90 degree each. Okay, let us start the proof now. In the proof, first you see I am taking here two triangles. One triangle I am taking here AOB and second triangle I am taking here COB. For that here I am taking two angles also. This angle I am supposing as angle number 1 and this angle I am supposing as angle number 2. Okay, so first we shall write down in triangle AOB and triangle AOB and I am taking triangle BOC. Okay, so now AOB, I think COB should be taken according to the one-to-one correspondence. So in place of BOC, we shall write down COB. Okay, that will be more better. Now, see, as I told you, ABCD is a rhombus. So it is a parallelogram as well. And if it is a parallelogram, then here sides, opposite sides will be parallel, or we can say that the diagonals will be bisecting each other. Okay, because in the parallelogram we know that the diagonals bisect each other. So AO and OC will be equal, BO and OD will be equal. Okay, so that all we will use it here. First we shall write down here AB is equal to BC. How we can say AB and BC are equal? Since ABCD is a rhombus, we have given that ABCD is a rhombus and in a rhombus all sides are equal. Okay, so we can say with the help of that AB and BC are equal. Second, I am writing here BO is equal to BO. Common side, you can observe BO and BO are common over there. So that we have mentioned here, right? And last one, as I told you before I have started, so AO is equal to OC. That we can say since every rhombus Every rhombus is a parallelogram. Is a parallelogram. Therefore, diagonal bisect each other. So if diagonals are bisecting, then AO and OC will be equal always. Now you see, with the help of side, the triangles are becoming congruent. So we can say now, therefore, triangle AOB is congruent to triangle COB. Okay, that we will say by side, side rule. Okay, now if these two triangles are congruent, then you observe angle 1 and angle 2 we have marked in the beginning. So that will be equal with the help of CPCT. So here further we shall write down angle 1 is equal to angle 2. That we will write down with the help of CPCT, and these two angle I am taking here X. So here we shall mention CPCT, and this equation I am giving as equation number 1. But if you observe, angle 1 and angle 2 are forming the linear pair. So 1 plus 2 is equal to 180 degree. That will say by linear pair. Okay. Now 1 and 2 both are equal to X here. So we can write down its value x plus x is equal to 180 degree. How we can say? By equation number 1. Now this will become x plus x is equal to 2x is equal to 180. 2 and 180, if I cancel, it would be 90. So therefore the value of x is 90 degree, and therefore we can say angle 1 is equal to angle 2 is equal to 90 degree. Okay, and you see, if angle 1 and angle 2 have proved 90 degree, I can prove the remaining two angles are also 90 degree each. I can mark angle 3 and angle 4 also. So here, if these four angles are proving we are 90 degree, we can say AD is perpendicular to, sorry, AC is perpendicular to BD, we can say. In other terms, we can say that AC and BD are also perpendicular. And if these two angles are coming 90 degree each, we can say that therefore AC is perpendicular to BD. Okay. So this complete the second example. Next time we shall see from the example number third. Thank you.